So on the bench today we have the Eico 315 single generator. Now, you know, a while back we did a cosmetic restore on the unit and got it looking good, and the unit was working pretty decent. There's a couple of quirks that's going on with it that I need to address, and one of them is I like to have it on 0.600 kilohertz, and we should be seeing a 0 here on the little fine-tune dial, and we're not. So that dial is off. I've got to go in and set it. Another problem is the audio output is no longer functioning. When you switch over to audio, you should hear a 400 hertz tone, and it's not there. So you know, when I got this thing, this is all I done was did a cosmetic. I didn't do any electrical restoration on it or anything. So the reason why I wanted to fix this generator is that, you know, we're doing all FT101 series, trying to get those back up and running, and you'll find that you will need a single generator. Now, you know, I have several single generators. I have the IFR 1200. We also have the HP 8640B, and you know, they are real nice single generators. But for the average person, they may be a little bit out of the price range for your average hobbyist to go out and find. I mean, even the IFR 1200, I'm still seeing them anywhere from $1,500 to $4,000 on eBay. So they're pretty pricey, and the 8640s are still going for some pretty decent money. You can pick up one every now and then for a couple $100, you know, but a lot of times when you find those, there's something wrong with them. These you can still find, not just the Eicos. I mean, you can get the Eico 324. Heathkit made several models. Lots of different model brands on these that can be had from somewhere, you know, $50 to $100, and they will do a decent job for what you need for working on HF radios or even CB radios. You can still, you know, get these things tuned up and calibrated, and then when they warm up, a lot of them are rock solid. So we need to take a look at this one and find out what's going on with it. Now, the 315 has a real good vernier drive in it, and that's one thing that I liked about it, because you could really fine tune on a frequency. But if you notice, I can turn this thing back and forth a little bit here without even moving the needle. So something has happened here that I need to address also and get that tightened up. Everything, you know, is bolted down right, and there's no problems there, so we're going to have to find out how to address this issue, and I think I know what the problem is. What we're looking at is the back of the unit at the tunable capacitor. Now, you know, you would think maybe that was backlash causing the problem with the gears mesh, and you can see here we have two plates and a spring in there to take up backlash. Well, that doesn't seem to be the problem. You can see I'm rocking the gear right there. Let me get something here to put up here so you can see it better. If you look at the end of the ink pen, you can see the gear moving. But if you look down here at the shaft, you can see the shaft's not moving. So this shaft is knurled here, and these two plates have teeth in it that are biting down into this knurled shaft, and that is where it's giving at, right there. So I'm going to have to find a way to either pin this metal and tighten it up on this gear. And just to show the tube line up here, we have a 6x5 rectifier tube we have a VR 150 regulator tube. Now this tube has a noble gas in it, and when it comes on you see it turn pretty and purple up here at the top, and that's a regulation. Here we have a 6SL7, and what this is our output tube and our audio preamp modulator. Over here we have a 6C4 tube, and these are original Eico tubes, and this is our high frequency oscillator tube. So probably the next thing I'm going to do is start checking these tubes in the tube tester and see what's going on. Now I have noticed this tube here, the audio tube. Let's see if I can zoom in on this. If you look up here at the top, here and here, you can see two dark spots, and that may be an indication that this tube is going bad. I have a new tube and it doesn't have these spots on it, so it's a good possibility that that tube is what's causing the audio modulation problem. So looking here on the underside, we can already see we have 4 paper caps in here, and they have to go. We've got to get rid of these. This is 0.22, a 0.47, a 0.05, and another 0.05. So we'll need to get rid of those and put some new ones in. Now this one here, someone's already changed it. This is a 0.001 microfarad at 600 volts. It's already been changed, but we're going to go ahead and change it also and get a new cap in there. The switches has already been cleaned, but we'll clean them again. Looking over here on the side, you can see our coils for different bands, and also over here we have our tunable variable capacitors for setting the frequency adjust. We can see here we have an RF shielded box. This is for our RF output section. It's in a nice tight shielded box. This is actually a steel chassis that has been copper plated. So everything that's has anything to do with frequency generation and power supply and stuff is all shielded within this box. Even the cover that goes on it, which is the big L-shaped cover, is copper coated, and that helps shield the whole unit. Okay, we got our 6SL7 plugged into our Knight 600B tube tester, and we'll check the first elements and we'll see what we have, and we're showing about 82 on the meter. So let's go to our second element in the tube and we'll check it, and we're showing just about 82. So our 6SL7 checks okay. So that is telling me that that's not where the modulation problem is. It's not in this tube. Okay, I have our 6C4 in, and we'll give it a test. And it's showing about 79 on the meter, which is well within specification and should work okay. I'm not worried about it this time testing the regulator or the rectifier tube. So here on the back of the unit you can see this metal can capacitor. This is a 10 by 10 by 500 volt capacitor. This is your main fielding capacitor. This is usually the main one that needs to be replaced. You know, because it's dealing with your power supply off your rectifier tube. You can see here on the schematic, this comes off of pin 8 of your rectifier tube, and you can see it, you know, it shows up as C10 and C9, but this is your dual cap. And what we're going to use to replace this with is a Ritchie Gold. This is 10 at 550 dual cap, and you have to use a clamp to hold it in. And you see we got 3 terminals on the bottom, your ground and your 2 positives for each 10 microfarad cap. These are very good quality capacitors, and a lot of them are used in audio circuits because they're, you know, good quality caps. Now most of the time I would either, depending on the equipment, you know, I would either restuff the cap, or I would just disconnect it and mount 2 under the bottom. But you know, you can't always go slack on capacitors, and this is a very decent capacitor used to filter this rectified voltage with. As you can see, we have our Ritchie Gold installed using a chassis capacitor clamp. We got that nice and firm and centered in the hole. And here we have a look. Now, you know, the old capacitor, it grounded through the outside case. This actually has a ground terminal, so we was able just to run a short jumper right over to this lug here on the original 2 holes that mounted the piece of steel that hold the can capacitor in. The chassis mount actually fit those holes, so we didn't have to drill any extra holes. And we'll go ahead and get the rest of the paper electrolytics replaced. So the next thing to do now is to get the rest of these paper caps out, and I have the new replacements sitting here ready to go in. And all these capacitors I got from justradio.com. No, I'm not getting no kickback from them. I just like using their capacitors. They're good people to deal with. So we'll go ahead and get all these changed out. Well, as you can see, all the paper capacitors have been replaced. I still have to replace this bypass cap across the AC terminals. I went through and made sure all the wiring is back where it needs to be, so nothing's touching. Whenever I replace these capacitors, I always put lead dressing on them. This helps that if anything, you know, was to fall across it or whatever, you know, you won't short nothing out. One thing I do have to dress is from the original builder. You can see there's a spot there that was soldered to the chassis. Does not look very good at all, so apparently his soldering iron wasn't big enough to heat that solder onto this steel chassis, so I have to work on that. But at this point I do want to just fire it up and give it a test and see if everything is working before I go any further. Alright, so I'll let the unit come up and run for just a minute so it'll warm up a little bit, and set it for 0.600 kilohertz, and I have the IFR on 0.600 kilohertz, and we'll have set our frequency range 10 kilohertz, and we'll turn the output up. Not getting a lot of output on X1. We'll go to X10. You can see it's come up on the spectrum analyzer, and we have some noise in the background. Going up to times 100. Got a very good single. I'll bring it down just a little bit. And we'll look at our frequency error. That's just about on 0. And now we'll turn on our audio and see if we have any audio. Alright, we now have audio. So now the audio generator in our 315 is now working, and that's just by replacing the capacitors. Check our attenuation. That's times 1000. Alright, well, we're looking very good so far. No problems. I need to address this loose motion in the switch and calibrate our fine-tune scale, but our needle is right on 0.600, so I can't complain there. That looks pretty good. So that's the next step, and then we can do an alignment and get everything zeroed in and see how it looks. Okay, well, I think I come up with a fix. After looking at this, the inner gear is on the knurls. The outer gear runs free, and it has the 2 springs on each side, and that keeps the backlash on the little gear. And after checking, there was no play in that small gear. So what I did was clean the metal of the inner gear, fluxed it, and got a real hot soldering iron and put a big blob of solder on this. Now, it's not actually soldered to the shaft, but what I've done, I put enough solder up here so it'll run down, and it runs down into those knurls, and that has tightened this gear up so it does not move on that shaft. So I'm going to clean this up a little bit and put a little lube on it, and we'll get it reinstalled, and I'll get the needle back calibrated and the fine dial, and then we'll go from there. So one of the problems that this unit has started having was low output, and then it got so it did not want to work on the higher bands. You know, this unit will generate 75 kilohertz to 50 megahertz direct, and anything over that is harmonic of the other bands. So the low output, the first thing I would look at is in the power supply system, and we see our rectifier tube, and here we have a regulation tube. We've already replaced these 10 microfarad caps, so the next thing in question would be these 2 resistors here. This is a 6K ohm resistor, and this is a 1K ohm resistor. Any changes in these resistor tolerance will cause the output power to become low or, you know, unstable. So we need to check those 2 resistors. So here are our 2 resistors. This is our 6K resistor, which is R13, and this is our 1K resistor, which is R14. I went ahead and pulled the tube and desoldered the one from the other so we can get a better reading on it. And that's our 1K resistor, and it is rating 5.2K. Our 6K resistor is rating 5.3K. So R14 here is way out of tolerance. R13 is about 1,000, well, about 800 ohms out, and that's out of tolerance for this, so we need to replace both of those resistors. I'm not sure if I have a 10 watt 6K in stock, so I'm going to have to search around. I might have to do a little bit of playing around and mix up some resistors to achieve that. So I have those two resistors replaced, and now we're going to look at the output. We're on B band. I got the tracking spectrum analyzer set to 600 kilohertz. Let's roll the frequency down. That's showing center frequency, and we see a real good, healthy single. A lot better than before, and if you look real closely you can see we're not that far off on our alignment. Now remember, the bottom cover is not on the unit, so the case is not completely enclosed, and that's going to make a difference too. Let's go up to our C band, and we'll put in 5 megahertz. And now our C band is working, and we got a good signal, and again we're not that far off on the meter. Yeah, that's C band. And look at the frequency error. We're on just about 0. Yeah, that's on 0. And our meter scale showing about 4.9. So just a little tuning to get that on frequency. Okay, I've gone through all the bands to make sure every one of them was working. The only band that's not working is band D. I'm not getting no output on band D whatsoever, and that could be this wafer switch might not be making a good connection, or it could be a bad capacitor or something in the band D tuning range. Right now I'm on band F on 20 megahertz, and it's off quite a bit. Let's see, band F, 20 megahertz is here, and we're about halfway in between 20 and 25 megahertz, so about 23.5 megahertz. And you can see the monitor is set on 20 megahertz, and we drifted a little bit off frequency since I turned the camera on, but this thing is very erratic on the higher frequencies. I mean, just touching the VFO. You can see just how erratic it is up there. And now I want you to remember that anything above 50 megahertz is using harmonics. And I've already read several posts where people do have problem with the harmonics on this thing not as stable as they should be. So we're going to have to see, can we address some of that issues, find out what's going on with it. Okay, just after that last segment I switched back to band D and set the IFR to 5 megahertz. And band D 5 megahertz will be way around here, and our meter sitting here. But if you look at the waveform on the spectrum analyzer, you can see how shaky it is. And you can move it back and forth. We can see it's very erratic. So I might have to do some more cleaning on this band switch. It could be something in there I'm not seeing that's causing this issue. But now band D is working. Okay, well, I think now I know what it is. I was fixing to move the unit while it was still on, and I noticed that it dropped out. But if I just flex the case, now you can see it's completely gone. Touch the case and it comes back. So I want you to remember that these, back in 1963, you could buy this unit wired or unwired. In other words, it came as a kit. Well, most people back then got them as a kit so they could get the enjoyment of putting it together. So this is probably a quality issue with a bad solder joint somewhere. Now I want you to remember there's a lot of rigid wires, especially off the tuning caps over here to set the alignment, and they're very stiff, and it could be a bad solder joint. Looking here in the 1963 brochure on Eico equipment, you can see how 315 came as a kit form for $49.95, or you could have it already assembled for $69.95. So back then these things were pretty cheap, and now these units are even going for more than that. So that just shows you the difference in the prices from back then to now. So being that, you know, this was probably a kit, and looking at it, I'm pretty sure it was a kit. You know, I'm going to go in there and see how to address some of these solder connections. Now, one thing to remember, that when you're working on a piece of equipment like this, is always try to, you know, if you take something loose, always try to route the wires back exactly like they were, and there's a reason for that. Now, I've noticed that modulation output jack over here, there's a red wire that comes from the back of it, and it's looping through these coils, and you can see it right here, how it's looped through these capacitors over here and around these coils. Just by going in here and taking this wire and moving it around, no single, single, no single, single. And I think you can see this with that coax in the way. There's a single, no single. So like I say, you know, the higher frequency uses harmonics, and when you introduce another field into that circuit, you can actually make that circuit drop out. So what I'm going to have to do is take this wire loose and reroute it back around the bottom of the shield through here and directly to that capacitor, and see if that takes care of the problem. So it's just by moving that one wire, you can now see that we have a good healthy single. It's a little shake in it, but you know, the cover's not on the bottom, and this is a harmonic frequency. But now, instead of picking up our 5 megahertz way around here on the dial, it is now over here where it needs to be. And just by moving this wire going to the audio output jack, which was creating some inductance in the circuit, which just throwed the whole circuit off. In fact, if the wire moved just the slightest bit, it would actually, you know, completely throw it so far out of calibration that the single would fall out. So sometimes, you know, when you're working on this stuff, it's very important to make sure that everything is laying exactly like it needs to be. It's one reason why it's important to take pictures, and in case you forget how something was. And also, if you can look online, you can look in the service manual how they routed the wires, and that'll give you some idea where to put them back at. Okay, now our generator is completely up and running like it's supposed to be. I went through, checked rest of the resistors, and inside the RF output jack behind the multiplier there are several resistors. There's 300 ohms and 3 1K resistors, and this is one of the 1K resistors that was back there that is swollen pretty good, and it checks at about 5K. So I went ahead and replaced that one, checked all other resistors, and everything's good to go. So it looks like all we need to do now is to go through and align each band so it'll read up on the corresponding band on the dial. And there's several ways you can do this. The way I'm going to do it is just use my spectrum analyzer to tune the band. Now y'all may not have that, so here's other ways you can do it. If you have a good frequency counter, and maybe on some of the lower bands you would need a preamp, but you could use a frequency counter to go through and line it. Not everybody has a frequency counter, so another way you can do it is to use either a good communication receiver that you have, or an AM/FM radio. You can align it this way. I'll show you another way that the manufacturer of this recommends to do it. Okay, this is one way that the manufacturer of the Eico recommends to align the 315. And what you would need is a 1N34 diode, followed by a 10K resistor, and we'll put that at ground potential. You'll then need two 200 microfarad caps, and what you would do is that this would go to one single generator, this would go to a second single generator. You come here to a audio amplifier, either like a IT12 single tracer or something equivalent to that, you know, that you can pick up audio with. So this here will go out to your audio amp. And the idea is you set both excuse me, both single generators to the same frequency. So like you put it on band A, you set it for 200 kilohertz on both. Let both units warm up good. And then if this is your 315 and this is whatever other single generator you use 0 beat. Turn the audio on and you can 0 beat the singles against one another. Very simple to do. Allen W2EAW also shows how to calibrate a frequency counter by beating against WWV, and this kind of works the same way. So this is another easy way to do that. If you don't have a audio amplifier, you can always tie into an AM radio through the audio circuit with a 0.01 cap and get the same results. So it makes it pretty easy to tune this and align it. So to help clarify, when you go to adjust the unit, you see you have one trimmer capacitor here by itself. This is band A. That's B, C, D, E, and G is on the same trimmer cap. So we'll start with band A, and I'm only going to do a few of these because it's, you know, it's redundant going through it. But we'll start on that and we'll adjust band A. So all you do is set it to band A. Come up here and set your needle on 200 kilohertz, and we'll use the spectrum analyzer to bring it on frequency. Okay, I got the monitor set at 0.200. We are on band A. I got our dial set to 200 kilohertz. I'll open the frequency error range open a little bit, and we're going to take band A trimmer and we're going to bring it right up till we're nulled on 0. We'll go back to 1 kilohertz where we can fine tune it. And there we are. So what I'm going to do now is we're going to go to band B. We'll set the spectrum analyzer to 0.550, and we'll go to 10 kilohertz error, and we'll tune trimmer B bring it up to 0. Go back to 1 kc error, and we're just about spot on. Alright, we'll go to band C. And we want 1600. 1.600, and we'll set our dial. Spot on. Go back. So we're over 10 kilohertz. We can get as close to 0. Put our error over. Ooh, she's turning us fast. And there we are, close enough. We're on band D. We got to set it for 5 megahertz, and you can see it's pretty much close right there. Just a little bit out. And there we go. Okay, we're on band E. It's set at 15 megahertz, and you can see it's quite a bit off. And these harmonics generated tune real quickly. Alright, she's dead on the money. Well, that will conclude the repair and alignment of our Eico 315 single generator. So we now have another old nostalgic piece of equipment up and running to use on testing our FT101s. So if you have any questions or comments, please leave them down below. If you found the video useful, please like, and if you haven't, please subscribe. And I'm going to put some documents on my website on the 315, and I'll leave a link down below. Anyway, I'd like to hear your comments, and we'll catch you in the next video. Thanks now.